Hello students, this is Dr. Ben. I'd like to work on a problem that has to do with the concepts of work and energy out of Chapter 6. So this problem has to do with a baseball pitcher, and we're told that the pitcher can throw the ball from rest up to 40.2 meters per second, and we want to figure out how much work is done on the ball by the pitcher in this process. So by using the work kinetic energy theorem, we can set the work done by that force equal to the change in the kinetic energy of the baseball. So that would be given by the final kinetic energy minus the original kinetic energy, which is 0, because we can assume the baseball starts from rest, and so that would be equal to 1/2 m times v final squared. So for part A of the problem, we're given that the mass of the baseball is 153 grams. So we convert that to kilograms, we get 0.153. The speed of the baseball after it leaves the pitcher's hand is 40.2 meters per second, and we would square that. Get our calculator out and multiply those numbers. 40.2 squared times 0.153 divided by 2. That gives us 123.6. I'll round that to 124, and that would have the units of joules. It represents work, which has the same units as energy. So the pitcher throws the baseball, and the force that he exerts equates to a work done on the ball of 124 joules. Alright students, we'll go ahead and continue on with this problem. So we had just figured out that there was 124 joules was the amount of work that the pitcher needed to do each time he threw a fastball. And then in the second part of the problem, we're asked to figure out how many fastballs could the pitcher throw by consuming a meal that is the equivalent of 1,520 calories. So I looked up the conversion factor between calories and joules in the textbook, and I already worked out that number. It turns out to be a little bit bigger than 6 million. And we're told that the efficiency of this process is 20%. So only 20% of the energy from the meal gets put into the throwing the balls. And so we want to find out the number of fastballs that the pitcher can throw. So we want to set up some kind of a balance equation, a conservation equation. So basically we're going to say that the number of throws multiplied by the work that's done for each of the throws, and so that would be the total work required to throw the fastballs, would be equal to the energy that is contained in the food. But then we have to multiply that by the efficiency, because only 20% of that energy is available. So I can do simple arithmetic and divide out and find this ratio. And so for our problem, we would have 6.36 times 10 to the 6 multiplied by 0.2. And then that would be divided by 124. Alright, so we'll get our calculator out. So 6.36 times 10 to the 6 times 0.2 divided by 124. And that equals 10,262. 10,262 throws. So I would say that this would be quite a challenging thing to do in terms of dieting. If you were going to lose weight by throwing the fastballs, it would take many, many times in order to burn off the equivalent of this relatively small meal. Alright, so there we go. The number of throws